So today the topic we are to see is sequence detectors. So we shall see the functionality of sequence detector and design sequence detector. So basically a sequence detector detects a specific pattern. So it can also be called as a pattern detector. So in general the block diagram will be looking like this. So you have a sequential circuit which has a clock to it and you will be receiving input sequence bit by bit. So you will be receiving one bit at a time. So you receive a bit at a time, and upon detection of the sequence you get output. So as the sequence will be obtained in a sequential fashion or a serial fashion, accordingly your output will also be obtained. So this is mainly used in communication applications where in case of digital communication where you will be receiving a sequence of zeros and ones as the input. In order to detect the message, a specific pattern might be required. So for that purpose, you can use a sequence detector. So the sequence detector can be implemented as Mealy emission or Moore emission. That is depending on how your output should depend on present state alone or present state and the external input, you can implement it accordingly. And the types we have are overlapping and non-overlapping sequence detectors. So the main thing with the sequence detector design is you need to understand the problem statement and draw the state diagram. So once you draw the state diagram, it will be similar to our normal sequential circuit design, where you will be having the state table after the state diagram, then you do the state assignment, and then you can find the flip-flop inputs, and then finally you can draw the sequential circuit. So let us see the design of sequence detectors. So in order to implement an n-bit sequence detector, if we are to implement it as a Mealy machine, this requires n states for implementing n-bit sequence detector, whereas Moore machine requires n plus 1 state. So here to draw the state diagram, the first thing what we do is you, as I was mentioning, with Mealy machine you need n states. So here let us consider this example. You have to detect a sequence 101. So we require 3 states. Let us simply name it as S0, S1 and S2. So here the first state, this S0 is considered as the initial state or the reset state. So now we need to move through the states. So for that what we do is the sequence to be detector is then given as input condition as we move from the initial state till final state. That is, here we are to detect the sequence 101. So this S0 is our initial state. So we assume that as we detect the sequence. So we are to detect 101. So when I receive an input 1, I move to the next state with output 0. Then as I receive the input 0, I move to the next state with output 0 again. Now last one, depending on how we are going to do things, we will be giving the final value. So we shall see the steps as we proceed. So this is what I meant. Okay. Now we need to analyze for the other condition. So with the input 1, I am going to the next state. So if suppose I am receiving the input as 0, I will remain in the initial state itself. And here if suppose I receive a 1, what we can do is we can remain in this state itself. Okay. So like this we need to analyze and complete the state diagram. So we shall see more examples. Now here we have an important thing, that is in order to give the condition or how we move from the final state for each of the input condition. So we have this conditions. This is important for you to do the analysis. So for non-overlapping sequence, if I am to detect a sequence 101 with a non-overlapping fashion, we move the last bit to the initial state. And if there is one bit overlap, we compare the last bit to the one bit state, and if it is two bit overlap, we compare the last two bits to two bit states. Likewise we go on. And for Murray machine, we have for non-overlapping sequence, we compare the last bit to one bit state. There is a slight difference in these two. You can observe this. We shall see example for better understanding. So now here I have considered a design of a sequence detector to detect 1101 as overlapping and non-overlapping sequence, and we shall also implement it using Mealy and Murray machine so that all the examples can be seen together. So first let us consider Mealy machine and non-overlapping sequence. So with Mealy machine, we know we need n states for n bit sequence or n bit sequence detector, right? So here we are to detect 1101, which has 4 states, that is which is of 4 bits. So we need 4 states. Okay, so let us assume the states to be S0, S1, S2 and S3. So this S0 is my initial state or the preset state. Now we are to detect sequence 1101. So what we shall do is, from the initial state, let me go to the next state for input 1 and my output will be 0. The next sequence that I need is another 1. So here also input is 1, output is 0. The next sequence is 0. So 0 and 0. Now here what we shall do is we shall put a small square box and write the sequence that we have attained. So at S1 we have received input as 1, and with S2 the input received is 1 1, and at S3 the sequence received is 1 1 0. That is, for detection purpose we are writing this way. Okay, now if suppose instead of receiving a 1, if I receive a 0 while I am in the initial state, what we do is we remain in the initial state itself. We need not go anywhere else. So let this be 0 0. Now for the other states, what we do is, so as I have received first one, if I am receiving the second one, I am moving to state S2. Now if suppose I receive the input as 0. Okay, this is the sequence I am receiving. First I have received 1 already, and at S1 I am receiving the input as 0. So now what we do is we compare this last bit to the value inside this. So if these are same or equal, we remain in the same state. So here this is 1 and this is 0. So it is not equal, right? So what we do is we move on to the previous state itself. So while being in state S1, if I receive an input 0, I move to the initial state itself. Next, coming to this one. So now I have received two consecutive ones, and if the next input is 0, it is in the order I am to detect. So it will move on. If it is a 1, what we need to do is we need to compare the last two bits with the state in this. Okay, if this is equal to the 2-bit sequence, then I can remain in the same state itself. So for 1, I am in the same state. If suppose this is not equal, what we do is we compare the last bit alone with the 1-bit state over here. So if that is same, then we will move from S2 to S1. If that is also not same, we go to the initial state. Okay, that is how that we are to do. Now coming to the last state. So with the last state 1 1 0. So in the non-overlapping sequence, what we saw is we need to have the last bit to the initial state itself. So what we do is, so after this I am to receive either a 0 or a 1. If I receive a 1, it is the sequence is identified. So for that condition, we will give the output also to be 1. If it is a 0, we go to the initial state. Okay, because our sequence will be broken over there, so we need to start afresh. So this is for 0 0, that is if I receive an input 0, and if I receive input 1, the sequence is detected and we get output as 1. Okay, this is how we do for Mealy machine non-overlapping sequence. Next we shall see the Mealy machine overlapping sequence. So Mealy machine and overlapping sequence. So when we say overlapping sequence, here we are to detect 1101. So obviously there is a possibility of only one bit overlap, right? Because following this you can receive a 101, so that you will be receiving this sequence. So here you are having a 1 bit overlap. So again here the sequence to be detected is 1101, which is of 4 bits. So we have 4 states. So S0, S1, S2 and S3. So the initial things are same, only difference is with respect to this last state. Okay, anyway I will explain that. So let us assume S0 to be our initial state. Then as per the sequence, we go from initial state to the state S1 when I receive the first one. As I receive the second one, I move to the second state S2. Then as I receive the 0 following two ones, I go to the next state S3. Okay, then from the initial state, if suppose I am receiving a 0, we assume that the sequence is not started, so we will remain in the initial state itself. Then the conditions are same. Here we have received 1 1. Here we have received 2 1. Here we have received 1 1 0. So now if after this particular one, if I am receiving a 1, I am moving to state S2. If I receive a 0, the procedure is same. So we compare this input with the state we have come across. So as we compare, this is not equal. So we move to this previous state. So 0, 0. Next, coming to this, we have received two ones consecutively. After this, if I receive a 0, we move to the state S3. If I receive a 1, we compare the last 2 bits with the 2-bit state. If this is equal, we remain in the same state. So 1, 0. Now coming to the last bit. So in the previous slide I have given for the last state condition. So here we are expecting a 1-bit overlap. So for 1-bit overlap, what we do is we compare the last bit to 1-bit state. That is, if we are to receive the final input as 0, 0, we compare this with the 1-bit state. That is this one. Okay. If this is not equal, we go to the initial state. So if I receive 0 as the input, our sequence is broken actually. The 110 sequence is broken, so we need to start afresh. And if I receive a 1 after this, as we compare, we see that these two are same. So what we do is we move to this state. Okay, so 1 and a 1. So you can check this as well. So for example, let us receive this sequence itself. So initially I get the value of 1. So I move to state S1. Again I receive a 1. I move to state S2. Then I receive a 0. I move to state S3. Then a 1. So I go to this S1. Okay. So now this is the condition that where the overlap occurs. So after this I have a 1, then a 0 and then a 1. That will give me the output of 1. Okay, so this is the procedural way to draw the state diagram. So next we shall see the Murray machine. Here also we shall see both overlapping and non-overlapping condition. Murray machine and overlapping. First let us see the non-overlapping. After that let's go for overlapping sequence. The same I am going to assume. So with Murray machine, we know for n bit we need n plus 1 state. So here we are having 4 bits, so we need 5 states. So let us assume S0, S1, S2, S3 and S4. So with Murray machine, we know the output will depend only on the present state. So what we need to do is we give the output condition also along the states. So our thing is once I receive 1101. So that is the sequence we have to detect. So the first one as I receive, I move to the next state. The next one I receive, I move to the next state. The next 0 I receive, I move to the next state, and the next 1 I receive, I move to S4. So only with this condition we should give the output to be 1. For all other cases the output should be 0. So whatever be the sequence given, with the last state you give the output to be 1 and give the sequence as this. Okay. And the procedure yet again here it is same as we did with the Mealy machine except for the last state. Okay. So here if I receive the input to be 0, I remain in the initial state. Then for others again it is same. So this is 1, 1, 1. 110 and 1101. This is what the sequence is. So if here after the first one, if I receive the next one, I move to state S2. If it is a 0, we compare these two. So if this is not equal, we move to the previous state. The input condition is 0. Here we don't write the output over there, so be careful about it. Then with the next one. So here if after receiving two ones, if I receive a 0, I move to state S3. If I receive two ones, then compare the last two bits with this. So here this is same. So we remain in the same loop. Then here after 0, if I receive a 1, our sequence will be detected. So it goes to the last state and gives the output to be 0. If the input received is 0, what we need to do is we need to check the 3-bit sequence with this 3-bit sequence. So here you can see these two are not equal. So next what we need to do is, I was mentioning this. So what we do is we compare the last two states, that is this last two bits 0 0 with the 2-bit state. So here again if we check, this is not equal. So next what we need to do is we need to check the single bit state. So the last bit is compared with this. So here again this is not equal. So what we do is for the input condition 0, we move to the initial state itself. As nothing was equal, we move to the initial state. Okay. And for this Murray machine, for non-overlap, what we need to do is after this, if I am receiving a 0, we compare this last bit with the 1-bit state. So here this is not equal. So again, if I receive a 0, if I receive a 0 as the input, we move to the previous state of it. So it is the initial state. So for input 0, I will move from S4 to S0. And if the bit received is 1, we compare this with the 1-bit state, and if this is same, we move to the state. So we come to this. Okay, that is Murray emission and the non-overlapping sequence. Now for this, we shall do for overlapping sequence. So Murray emission and overlapping sequence. Again, the same way, we have 5 states for detecting 1101. So I have included the outputs as well over there. S20, S30 and S40. So S41. So as I mentioned for Mealy emission, here also the procedure is same, only the last state differs. So 1, 1, 0, 1. And if we receive a 0 initially, we remain in the same state. Then the states sequence 1, 1, 1, 1, 0 and 1, 1, 0, 1. So now here we shall start. So if I receive a 1 after coming to the state S1, it is going through the sequence, so it moves to the next state. If it is a 0, we compare. This is not equal, so I move to the previous state. Then here, if it is a 0, it moves to S3. If you receive a 1, you compare the last 2 bits with this 2 bit. If it is same, we remain in the same state. If it is not same, we will check the last bit with the 1 bit value. That's how the procedure is. So this is 1. Now after this, if I receive a 1, I move to the next state. Instead, if I receive a 0, we compare the last 3 bits to this. So this is not equal. So I compare this 2 bits with this 2 bit state. This is not equal. So I compare single bit state. Again, this is not equal. So we move to the initial state. So for 0, I move to the initial state. Now we are in the last state. So here again, with overlapping sequence, this will be a 1 bit overlap as I mentioned with the Mealy machine. So with 1 bit overlap, what we need to do is we should compare the last 2 bits to 2 bit state. So after this, if I am going to receive a 0, let us compare this with this one. So this is not equal. So we shall move on to compare the single bit. So that is also not equal. So for input condition 0, we will move to the initial state. Okay. And the next condition, if I receive the input as 1. So we check the last 2 bits with the 2 bit sequence. So here it is same. So from this state we go to state S2. So this is for input 1. Okay. So this is how we do this sequence detector. So for any sequence this applies. If it is a sequence 11011, 10101, 1011, whatever be the sequence, the procedure is same. Okay. So practice this for different sequences and you can try as Mealy machine, Murray machine, overlapping, non-overlapping. Detect the sequence 11011, 10101. These are just random examples. 1011. Anything it can be. Any sequence, the procedure is same. Just you need to remember. Okay, you can implement this as overlapping, non-overlapping sequence, or even as Mealy or Murray machine. Okay, so practice all these. We shall continue in the next class. Thank you.